Hey guys, welcome to our next flipped video lesson, which is part 2 of Target 5. Now what we're going to do is take the properties that we learned in part 1 and actually start writing and finishing proofs and putting them together in a logical sequence which explains how we get an expression from where we start to where we finish it fully simplified. Now proofs can be a little bit difficult, so I thought we might need a little bit of extra motivation to help us really get after it, you know, and somebody who I always look at and think, man, that person has great tenacity, great effort, never gives up, and is pretty awesome, is none other than Jimmy Buckets. That's right, Jimmy G. Buckets right here. Fresh off his new contract, a Bull for 5 years. Jimmy, are you ready to help us work on some proofs here? Oh, that's awesome. Jimmy, let me ask you, other than playing basketball, is pretty much doing math your favorite thing in the world? Oh, that's great. Well, let's take an example from Jimmy Butler here, and let's get going on these proofs here. So, with that being said, let's get right down to how we talk about our proofs, their properties. And the word proof we hear a lot of times on like TV shows with cops and detectives and lawyers in court, that you need proof. You need evidence as to why you're saying what you're saying is true. And that's the same thing what we're going to do here. We've been doing work to simplify expressions, and what we need is proof that our work is correct and that our answer, our final simplified expression, is true. So let's take a look at this expression here. This is something we would use order of operations to simplify, and we would simplify it down to 0. So take a look at those steps for a second. Just make sure you agree with all the work that was done. But what we need to now be able to do to complete the proof is to give a reason why we can do each step. Remember that question, why again? So the first question, why do you have this expression? Well, it was given to you. For most algebraic proofs, 99.9% of them, the first reason, the first proof, evidence you're going to give is that it was given to you. After this, though, you did work to get down to 0. So how did we go from 3 times 3 to 9? Well, that was our substitution property. 3 times 3 and 9 are equal to each other, so we replaced the 3 times 3 with a 9. How did I go from 9 minus 16 to negative 7? Well, again, this was the substitution property. 9 minus 16 is equal to negative 7, so I can switch them, substitute them. So then we went from 7 plus negative 7 to 0. And if you remember, this is our additive inverse property. Anytime we add opposites or inverses there, we're going to end up with 0. And then our last step here, 0 times 13 is 0. Hopefully you remember that's our multiplicative property of 0. So we have just now given a proof for every step here. We've given evidence that supports the work we did, and if somebody objectively was looking at our work, they could have confidence that what we said is true because of the proof, the properties we gave. Now, one thing to notice here is that technically the substitution property is used in every single step. But there will be steps, like the last two there, where we use the substitution property and another property to prove what we're doing. If we're using both, just write the other property. Just write additive inverse property or multiplicative property of 0. You don't have to put both down. And you do have to identify the other property. If you just put substitution property for every step and left out additive inverse and the multiplicative property of 0, you would lose points in that. We want to know that you're really understanding the properties that we're using here. Let's take a look at a couple more examples here. So again, the work is done for you there. We've done all the simplification. What we need to now do is go through the steps. Well, again, the first step is given. Then 5 times 0, multiplicative property of 0. 7 plus 0, additive identity property. 7 minus 6, that's the substitution property. And then 11 times 1 is our multiplicative identity property. Again, I went through that kind of fast. If you need to pause the video and rewind and look through it again and look at your notes from the previous part of this target to make sure you understand those properties, please do so. Let's take a look at another one. This one's a little more complicated here. So the first thing we do is 5 squared is 25. Oh, I'm sorry. The first thing we do is given. Then 5 squared is 25 is our substitution property. 25 minus 20, substitution property. 1/5 times 5 equaling 1 is our multiplicative inverse property. Remember, we can always put a number over 1. So that's really 1/5 times 5 over 1, reciprocals. Then we have 1 plus negative 7, but I reversed the order of those terms that I'm adding. and that is using our commutative property. Anytime we change the order of what we're doing with addition, the order of the terms, that's the commutative property of addition, and then negative 6 plus 1 is, again, the substitution property. So we've done a couple of examples together here. So now what we want you to try is a couple of examples on your own. So I'll give you a hint. The first step rhymes with ribbon. And if you don't get it yet, that's okay. Ask in class. I'll explain it to you. But what I want you to do is to go through this just like we did in the other ones and give a proof, give evidence, give a property for each step of the work that was done to simplify these expressions. So go ahead, pause the video, and give us the proof now. Welcome back. Let's see how we did here. So we have the given, substitution property, and multiplicative identity. Those would have been our reasons why we could do those steps. In number 2, it's a little bit longer. We've got given, substitution property, additive inverse, substitution property, multiplicative inverse, and then additive identity property. Well, this is a little introduction to proofs, and this is something we'll be practicing a lot more. You'll have the opportunity, I should say, to practice this a lot more. A lot of examples to work with these properties and get familiar with them. And you're going to need to do that because we will be expecting you to be able to do these same kind of proofs and identification of our properties when it comes to our assessments. Again, if you have any questions, please ask in class. Jimmy, don't you think they should ask questions in class if they have any? Right. Jimmy thinks you should, and so do I. Well, that brings us to the end here. So hopefully you got this, and we'll see you in class.